Hi, I'd like to show you now how to work with the EDOs in the PitchGrid plugin. And in this video, I am limiting myself to the case of the Western diatonic scale, which has 5 large steps and 2 small steps. And to understand how the diatonic scale hosts different EDOs, um, I show you a slide, a table that I just created. So here we have the EDOs that fit the Western diatonic scale well, which has 5 large steps and 2 small steps. So normally we are calling the large steps whole tones and the small steps semitones. This comes from the 12 EDO, basically, where the large step is exactly double the size of the small step. And the math is you have 5 times the 2 divisions of the 12th dead plus 2 times 1 division of the 12th dead, and so you get the 12 EDO, 12 divisions for the 5 large and 2 small steps. And we can do this for the different EDOs, like 7 EDO would be the large and the small steps are the same size, and the math is 5 times 1 plus 2 times 1 equals 7. And of course we also have the 17 EDO, 19 EDO, 22 and 31 EDO, which fit nicely and are popular choices. So the 17 EDO has the large step is 3 17 divisions, and the small step is 1 of the 17 divisions. And the math is 5 times 3 plus 2 times 1 equals 17. So similarly with the 19 EDO, where you have 19 TED divisions and 2 19 TED divisions for the large step and the small step respectively, you have 22 EDO where it's 4 and 1, and you have 31 EDO where it's 5 and 3. And the accidental step is sometimes the same. For 7 EDO and 12 EDO, it's the same as the small step. And for all other choices, it's a different number, and it's always equal to the large step minus the small step. So this is if you want to go from F to F sharp, this is the number of steps you need to apply, right? So let's see how this works in the PitchGrid plugin. So in the PitchGrid plugin, we can switch on, first of all, the equal division tick marks or PitchGrid ruler marks, and here we see that the octave is being divided equally to this number of steps, and the number of steps you can configure here. So let's first go to the 19 EDO case. So I'm setting this to 19 steps, and then you see the pitch ruler marks, the 19 divisions, and the C is 19 steps, and then the D we want to have at 3 steps. And now we can use, if I mark those nodes, I can simply hit the optimize button, and the optimize button will bring the C to the 19th division exactly and the D to the 3 divisions, and you see how the pitches now line up. So the large interval has 3 steps and the small interval has 2 steps, and adding an accidental, so going from F to F sharp, adds 1 step. So but of course we do not have all the 19 TED pitches assigned to a note on a piano keyboard, because an octave has only 12 notes. We can, if we want to access all the 19 pitches on the piano keyboard, we can change the mapping and increase the number of steps that get mapped. And with 19 steps mapped, we have all the pitches of the 19 that are available. But of course, the piano layout got messed up. It does not fit the scale anymore. But if you have an isomorphic controller, there will be ways to map this scale nicely, nevertheless. And here you see that the F sharp is not equal to the G flat anymore, obviously. Okay, so let's repeat this with the 22 EDO. 22 EDO, the D is mapped to the 4th scale degree and the C to the 22nd. Let's hit optimize. And here we are in 22 EDO, all the pitches line up, but some notes are missing. So let's increase the mapping size by 3. So we have now 22 steps mapped and we have all the pitches available. This is 22 EDO. You can do the same with 31 EDO. And let's see. Oh, by the way, you can also select other notes like the G. But yeah, I mean, the D must be, so if I now would hit optimize with the D at, now the D is closest to the 6th degree in 31 EDO. This would destroy my lattice. So I have to make sure that before I hit optimize, I have to make sure that D is closest to the one tick mark or ruler mark that I want to have. So for this, I adjust the skew parameter to bring it close. And now because D, I want to have the 5th scale degree in 31 EDO, I hit optimize, and then I have 31 EDO. The pitches line up nicely. So if I hit the wrong one, then this will destroy my scale, and it's not what I want, right? This also can bring me outside of the Western diatonic logic. So you have to be a bit careful with that, but if you keep in mind the table, so what you are intending to do, then you know what tick mark, what pitch ruler mark you have to adjust to. Good. So let's go back to the 12th dead. In the 12th dead, you see that the F sharp and the G flat are mapped to the exact same note. And this is of course because the small step and the accidental step are the same size. Okay, I hope this helps you to access all different EDOs for the Western diatonic scale. And if you go outside of the range of the diatonic scale, it's other EDOs that work best, obviously. So let me show you that. This scale, for example, hosts the 13 EDO. Oops, like this? No. Like this? Oh, yes. And I have to increase the step size by 30 steps. So this particular scale has 5 large steps and 3 small steps, and the large step now is 2 13 EDO steps, and the small step is 1 EDO step. And for this scale, we could determine other nice EDOs by changing the step size. So for example, if you want the large step to have 3 EDO steps, then we add 5 to the 13, which gives us 18. So let's see, 18. And we want the large step to have 3 steps, 1, 2, 3 down. Yeah, and if we hit optimize, we see that the scale nicely fits into the 18 EDO. Having 5 large and 3 small steps, with the large step having 3 EDO steps and a small step having 1 EDO step. Okay, I hope this helps. And have fun with the PitchGrid plugin. See you.